Let's understand the stack operation and its implementation. So we try to understand this stack operation with the help of array. You can apply this stack also in case of linked list or any other data structure. So consider we will use here array, and this array will be stored in the form of stack. So in this case we are representing the stack operations with the help of this array, and the name of this array is stack, where the size is 4 and the indexes are 0, 1, 2 and 3. So stack is having one unique property, and that property is last in first out. It means the element that will store into the stack last will be take out first. So let's first try to understand the insert operation in stack in this array. So let's say we insert one number in this stack. So basically we are inserting the number 12 at the index 0. So it is the normal insert operation in case of array. Now in this case we keep track of the latest number index that is inserted into the stack. So the latest number that is inserted into the stack is 12 and its index is 0. So we keep track of the indexes of the latest number that is inserted into the array. Now let's say we insert another number in this array, that is 15. So the index of this number is 1. So we have to keep track of the latest number that is inserted into the stack. So the latest number is 15 and its index is 1. So this is the insert operation that is happening. It is a normal insert operation in case of an array also. The only thing is we keep track of the indexes to those number which is latest in this particular array. Now let's say we insert another number. So we insert here 5 and we keep track of index. So basically the top of this particular array, the top index is 2, where we have the number as 5. So we always keep track of the latest number index and we call it top. So basically this top is nothing but the variable that keep track of the latest number that is inserted into this array, and the name of the array is stack. Or you can say in case of the stack terminology, we always keep track of the index of the top of the stack. So this is my stack where the index of the top of the stack is 2 and its value is 5, and this top variable will always keep track of the index of the top number in this stack. Now here we are inserting it, but in case of stack terminology we call it push operation. So basically whenever we are inserting a number into any kind of a stack data structure, then we call it push operation. So as we showed you that when we insert the number into the stack, we increment the value of top also. So these are the two operations that happen in case of stack, and this is the push operations, and this operation will take O of one time complexity. So this operation is pop. This is my top, which always keep track of the top of the stack. Now similarly, let's see the delete operation in case of stack. So whenever we want to delete a particular number from the stack, we first take out the number from the top of the stack and then decrement this variable. So now this variable top is right now pointing at the index 1. Previously it was pointing at the index 2. So first we take out the number that is on the top of the stack and then we decrement the value of top. So now right now top is pointing at the index 1. So this is the delete operation that happens in case of stack, and in stack terminology we call it pop operation. So when we insert it we call it push, and when we delete it we call it pop, and these both operation will take O of one time. So if you noticed here we are using the last in first out operation. How? So in the top of the stack previously we have 5. Now the 5 is the latest number that is inserted into the stack, and once we perform the delete operation we take out the latest number from the stack and then decrement the value of top. So we are performing the last in first out operations. The number that is inserted last will take out first. So that's why in case of stack we always perform the last in first out operations. And similarly we have the push and pop operation. Like currently if I print stack top, so top is pointing at the index 1 and this stack top will return me the value as 15. Let's see the implementation of stack and the push and pop operation. So this is my class, that is stack, and here we have the three data members, that is max size, then we have the array and the name of the array is stack, and then we have the variable that is top, which always keep track of the index of the top number that is inserted into the stack. And then we have the main method here. So in the main method, I'm creating the instance of this class stack. So this is my class, that is stack, and here we are creating the instance of it. And here we are passing the size of the stack. So the size here we are passing as 4. So what will happen? We assign this value 4 into this max size, and then we create an array of size 4. So basically we will create an array of size 4 and the name of the stack is stack itself. The name of the array is stack, and then we have the 4 indexes, that is 0, 1, 2, 3, and initially the value of top is -1, and then we call the method here push. So we call st.push, and here we pass the value as 12. So in this push method we pass the value as 12. So here we increment the value of top. So once we increment the value of top, the value of the top will become from -1 to 0, and at stack 0 position we insert the value as 12. It means in this array at index 0 we store the value as 12. So this is my push operation, where we first increment the value of top and correspondingly insert the value 12 here. Now next time we again call st.push and we pass here the value as 15. So it means in this method we pass the value as 15. So we have to keep track of the top of the stack always. So currently the value of top is 0. It means right now it's pointing to the index 0 in this array, and then we increment the value of top. So we first increment the value of top. Now top is pointing at the index 1 of this array, and then at one position we insert the value as 15. So these are the two basic operations that is happened during the push operation. We are incrementing the value of top and correspondingly insert the value. Next time when we want to insert the value as 5, so we pass here the value as 5. We increment the value of top, that is plus plus top, and then at the index 2 we insert the value as 5. So this is the normal push operation that happens in case of a stack. So here we have the stack of size 4 and we have inserted the 3 elements. It means we have done the 3 push operation in my stack. Now let's see the pop operation, that is the delete operation in this stack. So this is my pop operation. So the pop operation is also very simple. What we have to do here, we have to take out the element from the top of the stack. Like right now top is pointing at the index 2. So when we call st.pop, we call this method, and in this method first we take out the value from the top of the stack. So the top of the stack is 5 here. We take out that number and then decrement the value of top. So now top is pointing at the index 1 in this array, and the name of the array is stack. So this is the basic pop operation that happens in case of an array. So we have the push operation and then correspondingly we have the pop operation. Now there is two more methods are there in case of stack. So the first is isEmpty and the second is isFull. So basically the purpose of this method is this isEmpty will check that whether the stack is empty or not. Similarly, this isFull method will check that whether the stack is full or not. And how we check that? So when we call this isEmpty method, we simply check the value of top. So if the value of the top is -1, it means there is no element that is present in this stack. So it means the stack is empty. Similarly, if we want to check that whether the stack is full or not, then what we have to do is simply check the value of top, and the value of top will be max size -1. So in this case the max size is 1, 2, 3, 4, that is 4, and max size minus 1 will give me the value as 3. So when the value of the top is 3, it means top is pointing at the index 3 of this stack, then we can say that the stack is full.